In the previous video, we have made our player character move directed by the input from the player and from the direction that we provide by rotating our camera around. What we will need to do now is to reuse this controller with an AI agent. So to do that, let's create a duplicate of our player, Ctrl D. Okay, let's drag him forward. Now what we will need to do is change it to the name to be agent. And let's remove our player input script. So remove a component and let's drag it to our assets to make the original prefab from it. Okay, now we will create a new material to make the bot distinct. So let's create agent material and let's choose the albedo tint and make it pinkish or purplish. Okay, and let's choose the agent dummy and let's drag our agent material, okay, to the dummy. Now the agent is in different color. Great. Now what we will need to do is to go to our scripts and create a new script, and let's call it a simple AI input. Okay, let's open it up. Great. Now it will need to inherit from I input, and we'll need to call Alt Enter and implement the interface. Now we need to delete these throw statements from both of those our delegates, and we can copy this and paste it below. Now we have our simple AI input behavior. We will have to direct our agent to move towards our player. To do that, we are going to create a couple of variables. First will be bool player detection result. And let's set it to be false, because our bot doesn't see the player yet. We need public transform eyes, or let's call it eyes transform. So this will be the point from which we are going to shoot our raycast. We are going to need to have a public layer mask, player layer, or player mask. We need to have public float vision distance and stopping distance. Now I know that we need to have stopping distance of 1.2 f to have it working properly. So let's set it like this. And for now that's it. What we will need to do here is to create two simple methods to get the position of our player and to direct our AI agent towards the player. For now, let's create on draw Gizmos to visualize how far our enemy will see. So let's set Gizmo color to color dot green by default, and if our player detection result is true, we are going to set Gizmos dot color is color dot red. So this will change the Gizmos color. Gizmos is the indication of what we want to show in the scene. So this will be, in our case, sphere. So Gizmos draw wired sphere. We are going to draw the wired sphere to indicate the range of our player or our enemy vision. So our eyes transform position, and the distance will be vision distance. Okay, now let's go back to Unity. Okay, we will need to add first the transform for the eyes to our enemy. So let's choose our agent, right click and create empty, and let's drag it somewhere in front of the enemy's face. Okay, maybe here. Let's call it eyes. Okay, now we will add to our agent our simple AI input, and it will start throwing exceptions because we didn't assign the eyes. So let's assign the eyes to the simple AI input. Let's also change the player layer to be player. Vision distance, let's set it to be 8, for example. And now you can see this sphere, this wired sphere, that is being drawn in our inspector, and this is the range of our enemy's vision. So the agent will detect our player if the player enters this range, approximately. Okay, so we should not have any more errors. Now let's go back to script and implement the rest of the code. Okay, so we need to have our update function. So let's create update. Here, what we will need to have is player detection result equals detect player. Okay, let's alt enter and create this method. And to detect player, we are going to simply say collider array hit colliders, and we are going to cast an overlap sphere. So physics dot overlap sphere, we are going to pass here eyes transform dot position. So from our eyes we are going to cast a sphere in vision distance, so basically the same as we did with our wired sphere. And what we also want to pass here is our player layer for it to only detect colliders with the layer of type player. Okay, and for each collider, to create quickly the for each, you just type for each and tab twice in our hit colliders, and we are going to say player transform. Do we have this field? No, we do not. So let's create a public transform player transform. Okay, and now we can assign player transform equals this collider dot transform, so we know where the player is, and return true. Okay, otherwise let's copy this statement, and we are going to set the player transform to be null in case we are checking it in some other function, and we will return false. Okay, so now we should have the functionality to change the wired sphere color if we enter the zone where our agent is being able to detect us. So let's go back to Unity. Okay, let's press play, and we can see that the enemy is constantly seeing us, so that's not good. And before we start playing, we need to choose the agent because we have duplicated it, and change its layer to be default, yes to all children. Now we can press play, and we can see that currently the sphere is green, but if we enter it, now it is red. Now our agent is constantly running because we are not passing anything to our vector 3 position, so it has some value for our for the animator, and this value doesn't change. Okay, let's stop playing. Let's go back to our script. Okay, so what is left now is to call our on movement direction delegate and on movement input delegate. So if we know that the player detection result is positive or negative, we can appropriately call what we want to call in those delegates. So if our player detection result is positive, we are going to call var direction to player equals player transform position minus transform position. So we are calculating the direction towards our player. So now we need to also cast it to be in the XZ plane only, because player can be a little bit higher than our enemy. So we need to cast it on the XZ plane. So we are going to call vector3.scale and do the same that we did for our player input. So direction to player and vector3 forward plus vector3 right. So we are going to nullify the Y direction. Now if direction player dot magnitude is greater than stopping distance, we are going to want to walk towards the player. So direction to player normalize. Okay, so we have normalized the direction. and on movement input, and we are going to check if it isn't null. If it isn't, we are going to invoke. And if you might recall, we have only implemented the movement if we are calling the up arrow, so the vector 2.up. So basically if y is greater than 0. So we can call it vector 2.up. But if you have preset it differently, you could have passed here the direction. Okay, but the direction will be important for on the movement direction input. So here we are going to again check if it isn't null, and if it isn't, we are going to pass the direction to player for the agent to rotate correctly, and we are going to simply return here. Now, in case the stopping distance has been reached, we are going to call on movement input invoke and vector to 0 to stop our agent from moving, and on movement direction input we are going to invoke transform.forward so the desired angle will be 0. Okay, great. So that's all that we need to implement in our simple AI input. Let's go back to Unity. Okay, before we test it, let's go to our agent and let's change its movement speed to 5. Let's press play. And we can see that if we enter the green zone, our agent sees us and stops just before us. We can run outside of this sphere. Now it has stopped. Now let's run towards it. And again, it stops just before reaching the distance limit. Okay, so we have this way implemented a reusable character controller movement system. So I hope you have enjoyed this tutorial. Now if you did, please subscribe, drop a like, and consider supporting me as a patron, and I will be glad to make more of those Unity tutorials. The link to the Patreon page is in the description. So take care, goodbye.